Dear fellow Zrilians, welcome to day 5 of my report about the events that took place on Emergency Station Europa, as it is now called. So let's get to it.
Hunger critical.
Today we have a few interesting things in store, hypothetically, depending on how far I get with my explanations. And for what I wanted to do now, I had to make a new IC housing. An interesting project would emerge, and I wanted to make it happen. I had to make happen a kitchen. I had to make happen a personal living quarter and an air draft for filtration, and all of these things would have to happen. But I had to choose different approaches, different targets, because I had an idea, and my engineer mind could not let go, and so I would have to go through with it. And for this experiment, I would also need a proximity sensor. You may wonder why I create another proximity sensor so close to the one I already had. With two IC housings in such close proximity, I would of course have to name them. And another 50 watts down the tubes, as the humans tend to say. Once more, my endeavors would be interrupted by the annoying fact that I would have to eat once more. Or twice more, I was unsure.
Oxygen critical. Hunger caution. Cognition low. Oxygen critical. Oxygen critical.
So in my little to-do box I had placed the logic transmitter, and this one would now come into play, or so I hoped. I just would not know where to place it. It would not matter much, so I picked out an arbitrary spot. Somewhere. Anywhere. And that's the spot that I chose, and no other spot I could choose. Only that spot. That is the spot that I could choose. Where was the spot I did not remember? What was again the connection for this device? Input, 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 and power. In other words, I would only have to connect to, the rest would not matter. I am pretty sure the rest only served to allow multiple logic networks to participate. Would this work? Yes, probably. What devices could I choose? The advanced tablet, and I could only choose the advanced tablet. Now, with the advanced tablet chosen, I would have to access the logic transmitter itself. Which itself did not have any logic connections, because it would just represent the device at hand, reminiscent of the logic mirror. Now it was time to take a look at the tablet. Its logic values were now relevant. Interesting, I thought. I was not aware that mode is a value that can be written. Instantly, I wanted to try this, but first I would have to use the on value, which surely should be writable. I would now try to turn the tablet on remotely. My ears told me this has succeeded. and succeeded again and again. In this fashion, now I decided to change the mode. Maybe this had worked and I had just chosen unfortunately. No, no effect was taking place. Mode 0 and Mode 1 both existed, but the mode did not take. This did not work. Not a problem, for my goal was a different one. I could write a sound alert. For example, 1, 2, 3, 4, 5, starting at 29.
One. One. One.
I wondered why this only took place once. And so, to mix things up, I would just choose to play different sounds. Maybe a change would trigger a new one.
2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2.
Now it would get slightly interesting, though this was not yet where I had hoped to go. The interesting part would come later.
One, 2. 1, 2.
I could remotely read the tablet's mode. In other words, I could use the mode to, for example, turn the light on or off remotely, if I would so choose.
2. 2.
Since I was in a playful mood, I wanted to also find out if I could just read out whether the device was on and use it in the same way.
2, 4, 2, 2, 3, 2, 3, 2, 3, 2, 4, 2, 4, 2, 3, 2, 3, 1, 3, 1, 3, 3, 1, 4, 1, 4, 1, 1, 3, 1, 3, 1, 3, 1, 3, 1, 3.
So far so good. I was capable of reading out the advanced tablets on and off state, and also which chip was currently being used. With this, I could now theoretically control things in the station. I could even carry multiple tablets and use them in a binary fashion. Currently, I had 4 values that I could express: on, off, and mode 0 and mode 1, 2 dimensions, therefore 4 different numbers. I did not yet know what to remote control in the station, but I knew something that I would like to express as sound on the tablet, and that was where the proximity sensor would come in. For this experiment, first I would have to do something that was unrelated to the tablet. Therefore, I just skipped the entire part and started over. I realized this would be the first time that I would ever leave out the yield command entirely. Or I wanted to run this code at maximum speed. I did not know if this would be feasible, but this experiment would find me the answer, which I was very much looking forward to find. On the right of my view, I could see my little sun clock tower move about, as the sun itself was also in motion, which, as we all know, is not quite true. Then again, it is, just not in relation to this object. I wondered if this would do the trick. Interesting that I would read 1 and 18, sometimes 1 and 19, I surmise that the execution implemented that the IC-10, which does not run all its lines in an instant but interjects a yield statement automatically, was doing just that, in a rhythm that was befitting the amount of lines it had taken to write this code. This was probably what was happening. Maybe I would have to use yield. And so I did.
Power low.
I realized it was necessary to install a small display device so that I could continue with my experimentation. And with small, I meant, of course, the biggest that I could muster. Seriously? I thought, with 2 question marks and 1 exclamation point. But yes, the answer was indeed. Impatient, I just continued my building instead on the ceiling. Well, if the computer does not work, yes, correct. Turn the dot set on again. had I used the proximity sensor prior? I was unsure. Activate. The question was, activate. So let me tell you half of what I am trying to do here. Though I'm sure some of you have already guessed the rest. Here is my program. I yield. Then I say right into the proximity sensor setting, which is the distance setting for the sensor, right dist towards it. Wait, can 0 even be set at all? Yes, it can be set. And the distance that I'm writing is a variable, which I initialize with 0. I guess that was my mistake. So I write this distance setting to the proximity sensor. Then I check if the proximity sensor was activated. I am not sure if this can be done right away or if a pause is required. Then I branch relatively 1, 2, 3. Wait, 1, 2, 3, 4, 5. I have to branch 5 lines. Maybe I should first try this before trying anything better.
Hydration critical.
I am not sure where the value on the LED would not change away from 1. Anyway, so once again, before I will explain this, I will move the yield statement to between where I set the setting, and then ask whether I was detected. Maybe this would change the behavior of the button. Yes, indeed, it was counting to 4 prior, and now it was only counting to 3. Now it was counting to 4. Now it was only counting to 2. So the code was doing something meaningful. And I could see on the display the distance that it had measured, 7 meters. You see, the proximity sensor cannot detect my distance, but it can detect whether someone is existing within the set distance. And then it can tell you how many persons there are in that distance. But by changing the proximity sensor's distance, I could surmise how far I would be away, which was the goal of this endeavor, or at least of the first half of it. The second half would pretty obviously involve the tablet. Now, doing it in this fashion was very slow. In other words, I could not use the approach in this way, or maybe I should try once more without the yield statement and just see what would manifest. The distance measured was only 1. All the time. So in other words, this did not work. I would have to give the sensor time to actually perform the detection process. So in this way, I could detect my distance. Now I would like to express this distance on my tablet in the form of numbers. The problem was, I only had the sound samples 1, 2, 3, 4, 5 available, which, if you think about it, is beyond ridiculous. Where's the 0? Where's 6? Where's 7? Then again, I am thinking like a human. We Zrilians obviously are using the 5 system, and so it makes sense to only count up to 5. Or something along those lines. Anyway, I would now try to convert the value that I had into such a system and then express it on the tablet by means of words. This was the following endeavor. I changed my approach here to minimize the probability of programming errors. So again, the source code. I was setting the distance 0 to the proximity sensor yielded, and then I was reading whether this would activate the sensor. If the value of activate was less than 1, I was just using this. I could also have used not equal, I did not care. It would just count up the distance to 1 meter, and then do it over 2, 3, 4, 5. Eventually, though, the distance would fit, and then, in consequence, the color white would be set to the LED, the distance would be expressed, the distance that hadn't counted up so far, yes. And then the distance value would be reset to 0, so that another count could be taken until it would once more activate. What I intended now was to also add into the mix the expression of the found distance in words on my tablet. How would this work? I would have to use a modulo, I was quite sure. How would this work? So I would have a number here, and now I would have to derive the 5 digits. This would mean I would have a loop. I copied the test value found to R0, for R0 would now experience alterations. Too bad, though. The number 0 did not exist in the audio sample list. Which was making this endeavor quite tricky. Therefore, I chose to use 1 for 1, 2 for 2, 3 for 3, 4 for 4, and 4 for 0. 5 would have been too confusing. Now I have found the current digit, and I would now have to express it. Afterwards, I would have to change the number. But first, I would have to check if the number was already 0. Because if it was 0, then no distance was to be expressed. I was not sure as to how to proceed, for division would probably not be an integer division. How could I make this happen? I thought that maybe rounding down might be the trick. Here I was dividing R0 by 5. Let's assume R0 would be 4, and I would divide it by 5. The result would be a positive number less than 1, so it would now become 0. If the number would be exactly identical to 5, then the result would be 1. If it was greater than 5, let's say 6, then it was 1.1 something, which would be rounded down to 1, so I now had my integer division. But first, I would have to try to express the number. How would I do this? I would have to choose the sound sample to play, and also I had a problem, because if the sound sample would be identical to a sound sample that had been playing prior, nothing would be played. How could I make this happen? I was not sure. Possibly I would have to express a different sound sample in the meantime. So I saw myself first test out this problem.
Floor. Floor.
Apparently, I could play another sound that instantly interrupted without consequence, other than the sound that I wanted to play would play unconditionally. So the problem was solved, but I was completely not satisfied with the idea that I did not have a 0. This was really off-putting. Maybe I should use fire instead.
Floor. 1. Fire.
This seemed appropriate, and was also working. Again, I tested this was out.
Fire.
Without the sound reset, it would only play once. So that problem had been tackled. I was not sure if there was an easy way to just select one of the values based upon the number that I had, and so I used the pedestrian way, which was really lame, but it was the only thing I could think of. I did not want to waste too much time on this. So, therefore, then I detected. I was assuming that the sound would have to be 0, except if it would not be. So I was assuming num 0 in R2. But if R1, my modulo result, would not be equal to 1, then I would skip all the next line, else I would write 1. And then I assumed 2, and 3, and 4, and that was all the assumptions I would have to make given the modulo that I had used above. At least that's what I hoped would be true. So to make sure this would be true, I also used the rounding method. Now I found the sound to play. Therefore I reset the sound alert, and then I played that sound. Then I would jump back to ED loop until the value would have descended into 0. And this should theoretically be the thing. However, I would have to hear it once more, as I would not hear the sound. Of course, I was walking to the LED to reduce my distance. Ha ha ha! But this did not actually reduce it much, for the display was not the sensor itself in person. But why was the sound not playing? I was confused. So instead I chose to just play a constant sound to see if that would solve the issue. And it did not. Oh, it did.
1, 1, 1, 1, 1, 1.
Temperature low. Oxygen critical.
Why was it so cold? I must have a leak somewhere. I wasn't aware of such a thing. Maybe I had been too active on other fronts.
1, 1, 1. 1. 1. 1.
Why was the room cooling down so rapidly? I was confused, and therefore I once again went to the computer, turned off my new script, because I wanted to measure with clarity where the temperature would be the lowest. And then I saw it. It must be this pipe connection.
1. 1.
I chose to remove the pipes in hopes that this will also remove the cooling effect. The cooling, though, kept continuing. I was confused. I realized this is something that is rather common.
1.
I mean that I was confused. This was indeed the coldest spot in the room. Why was this so? I assumed that since there's such a thing as an insulated passive vent,
Hunger caution.
removing the other such devices from the wall might be helpful. Oh, and then I saw there was still this blown pipe, but it was insulated. Was it bleeding into the room? Was this the reason for the shenanigans?
1.
The temperature was still ascending. So it was very clear that it was happening. I had now removed that broken pipe.
1.
Investigated the temperature once more. Now the temperature was even increasing, so this part of the room was equalizing with the rest. In other words, this whole time the broken pipe had been cooling down the room by its openness. Few people know that you can also, many people know that you can also force a passive vent quasi by building some pipes, filling those pipes, and then bursting those pipes by dismantling some of them, which will overpressurize the rest. But few people know that if the burst pipe is at a window or other thin wall, then this pipe will leak to both sides of the wall. And so I assume that the whole time I had an interestingly effective cooling solution going on. Now, of course, I would have to countermand the situation that had emerged. The plants were taking damage, but I did not fear, for I had the most powerful heating equipment ever devised right here in front of me. This should already be enough. The temperature immediately rose significantly all throughout the station, And once more I was reminded of how incredibly uninsulated the furnace really is, and that it would therefore require its own room, where it could boil everything if it so desired.
One.
As the pipes were heating up, so was their content, and thus overpressurization was taking place. Now, I would have to hastily remove them without removing my station. But I succeeded. Thank you for the applause. Now, returning to the topic at hand, wondering where my labeler might have ended up being. It was really interesting that all it took to heat the entire station from 0 degrees to 35 degrees was 3 little clumps of ice. 3. Volatiles are really a blessing, and we can be proud that we breathe the dragon's breath.
One.
So, what was the reason that my programming would play the sound that I wanted it to play, but not when it would logically make sense? For this, I had to output the result of the calculation to the debugging housing.
One.
The value was always 0. So I must have misunderstood the purpose of the modulo function. I found the explanation woefully insufficient. And then had possibly found the reason. A stupid blunder on my part, and so I assumed yes, of course. Resetting the distance to 0 before evaluating the distance could not prove fruitful.
Hunger critical.
My hunger was once again critical.
Hunger caution. Oxygen critical.
Now, why was this not working? What I wanted to do here was as follows. I would be starting with the distance. Let's say the distance will be 7. Or the distance would be 6. Yes, the modulo was working, but I was actually doing it wrong. I don't know exactly what I was expecting. I wanted to find the rightmost digit in the 5 system, and for whatever reason, I could not come up with the answer right away. It is probably easy for you now to point and laugh and know it, but you were not in that situation that I am in right now. So, what could be the answer? Let's say I have the number 7. I want to know how many times the 5 is there. It would then tell me it is 1. But what if the number that I have is 11? Then the 5 would be in there twice. Oh yes. This would actually make sense. But why was I not hearing anything from the tablet? That was the actual mystery.
One. 3, 1. 4.
And I succeeded?
3. 4. Fire 1. Fire 1. Fire 1. Fire 1.
Was it in the wrong order?
1. 4. 1. 4. 1. 2. 1. 1. 1. 1. 1. 1. 1. 4. 1.
So it was now telling me
4. 1.
the remainder 4, and then
4. 1.
I was actually not sure, so I left the station behind.
4. 1. 4. 3. 4. 3. 4. 3.
Or 3 for 19.
2. 3.
And 2, 3 for 17.
2. 3. Fire 2. 2. 2.
I'm not sure what I was expecting.
Fire 2.
But I was certainly not helped
1.
by the fire. It
1.
was
1.
just irritating. And so I just chose
1.
to shift the numbers by 1 and not give a flying
1.
fuck.
4. 2. 3. 3, 2. 5. 5. 4. 5, 2. 2, 3. 1, 2, 3. 4, 1, 3.
The idea seems to work.
4, 5.
And now I choose to accelerate the system tenfold.
5, 2. 4, 2. 1, 2. 1, 2. 5. 2, 2. 2, 2. 2, 2. 2, 2. 2, 2. 2, 2. 2, 2.
Hydration critical.
2, 2. 2, 2. 2.
What?
2, 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2.
Nice.
Oxygen critical.
I wanted to know, and so I had to test. Should I not speak now?
2. 2. 2. 2. 2. 3. 3. 4. 5. 1, 2. 2, 2. 3, 2. 5, 2. 2, 3. 2, 3. 2, 3.
I did not have to decipher the numbers.
2, 3.
I just would have to know what more or less meant.
3, 3.
I was now further away. Or 3 would mean even further away.
3, 3,
The number was basically being read to me from the right to the left.
Power low.
5, 3,
In 10 meters steps. This seemed to actually work.
2, 4, 3, 4, 3, 4,
This would also tell me when the station was on fire.
4, 4,
So it would no longer be able to radio anything to me. I would be confused. So I could go back to it quickly, but I couldn't because I had no way to go there. But this never happened.
4, 4, 4, 4,
The idea of this whole endeavor, of course, apart from the interesting challenge involved, was
4, 4,
to use this system to find my way home without using the trigger cartridge.
4, 4,
Now I hoped I would get lost,
4, 4,
instead of somehow remembering that the direction was definitely this one. I was so sure. Let's see if I was correct.
4, 4,
Yes, I was correct. Damn. Now I wanted to get lost,
4,
but could not.
4, 4,
Anyway, soon I would then expand this to also warn me of storms.
4, 4,
Oh, right.
3, 4,
And then the sun came, and once again told me where to go. I hated it dearly.
3, 4, 3, 4,
A rare configuration showed itself in the sky.
2, 4, 1, 4,
Jupiter and 2 of its moons, oriented like this. Now we could only see one, but I was sure the second one would show up again soon.
1, 4,
It should show up here, the smaller one, I believe.
1, 4, 1, 4,
It gave me the finger though, and it did not show up.
1, 4,
I did not have time for this.
1, 4, 1, 4, 1, 4, 1, 4,
This would also give me a constant sense of how far away I was from the station.
1, 4,
Because the further I would be, the longer it would take, the slower the frequency of the words would be.
1, 4, 5, 3,
I saw gold and became greedy,
5, 4,
promising for the experiment I was about to conduct.
four, 5,
I was certainly further away now from the station. For the frequency was way lower. Actually, very much lower what was happening. How could it be this low?
5, 5, 5, 5,
What had happened?
5,
Had my station blown up? I have never had this problem before. I wondered if possibly calculation distance, or if maybe might be no way so far from the station was somehow preventing the ship from functioning. Something I would call a catastrophe. That must never happen. But maybe that is what was happening. So, in passing by accident, I happened to have created a debugging tool for our mission administrators to find out at which distance the ship would ever stop calculating. Theoretically, if I would move in the direction of the station, I would once again hear that voice. I had overlooked so much gold. I was taken aback.
Five, 2, 5, 4, 5, 5, 5,
It appeared that the distance at which the chipper would stop rendering, for reasons that I would really have to bring up with administration, was 250 meters.
5.
Right, there was me turning the thing on, that didn't count.
3, 2, 4.
250 meters. And so I took, I don't know, a screenshot of my head-up display.
Hunger critical.
5, 5. 4, 5. 5, 4.
I was closer.
3, 4.
Power critical.
5, 3. 2, 3.
Closer.
5, 2.
Closer.
4, 2. 4, 2. 4, 2.
Damn, I was seeing the goddamn tower.
2, 2. 1, 2. 5. 4. 3. 3. 2. 2. 2. 2. 2.
Now, before I would continue on with my next step, I would have to take a short break. I will see you in a few seconds. Excuse me, sorry for that. So, now with that out of the way, I would have to get rid of my various things that I had in mind. And I would also like to try the Counterflow Heat Exchanger, which I have so far not yet employed. This heat exchanger was a simple one. The Counterflow Heat Exchanger struck me to be potentially more interesting, but ultimately I realized my door cooling solution was ultimate. These plants, they would not be here. This is not a greenhouse, so I do not need CO2 in this room, really. I wouldn't care about the mixture, just about the temperature. This room was merely functional. But I also had an idea regarding Invar. Do I have Invar somewhere? I had an idea regarding the greenhouse. It would also have to be kept at proper temperature, and so I decided I will make a room, and that room will also have such an automatic door. This room will house tanks, just like these tanks over here. One tank will have CO2, one tank will have oxygen, one tank will have nitrogen. And these tanks I would then use for my greenhouse. They would be inside a room, and I would fill these tanks from various sources, and it would adjust the temperature of the room up and down, and so the tanks would equalize themselves with each other over the room, and the room could also be used by means of emergency door. Ultimately, they would, by sheer mass, make sure that the temperature would always be alright, even if I would be adding much hotter and much colder gas. This then would be my gas source for the greenhouse. The greenhouse itself would be kind of like this corridor, except maybe 2 or 3 spheres wide, and it would have on this end, it would have the tanks, because the tanks would also have to be filled from some source, and I had a source right here, whose waste gas I could then use. Or by another source. Anyway, and then on the other end of that corridor, there would be a pump that removes gas from the room, somewhat, not much, using a back pressure system. And this then would be piped back here, where the tanks are. And the tanks will of course have some filtration units, which would then also be fed from the furnace. And now they would also be fed from what I would be pumping from the back of this corridor. So I would always have my separated gases, and I would choose which gas I would have to feed into the corridor, and because there would be a draft, I would constantly replace the air of the corridor and make sure that the plants would all have the correct gas and temperature. This sounded like a good plan to me, particularly the part where I would house the tanks in a room and automatically would vent the room by means of emergency door. Or possibly I could even automate the furnace, or an arc furnace, or maybe the advanced furnace. All of this was possible. These thoughts were going through my head when I was about to wonder where the Invar went that I had. Was there no Invar left? Yes, there was Invar. So I would not have to make a new one right now. Very good, very good. And now it was time to heat up the furnace once more. No, maybe I should start first with the Counterflow Heat Exchanger experiment. After all, the answer to the cooling of this room might lie therein. Therefore, I wanted to do this. Of course, I would have to remove this exchanger, but first I wanted to see. So here was the input and here was the output. But there was also an input on this side. Gas, gas, liquid, liquid, and liquid gas. I was not sure, and so I would just start the entire experiment over. I would just start with gases. Time to dismantle the heat exchanger, which was thankfully a very fast undertaking. This device would definitely be in the way if I would place it in this way, because then I would have placed it in this way, and this is the way that I have to walk. What would be the next step in the construction of this device, I wondered. A welding torch and steel sheets. Interesting. Mixing things up, I see. Oh, that was already the entire construction. This would not prove an easy undertaking. I was not sure how exactly to proceed, and so first I removed the code that was still in there for those switches.
Caution.
No time to waste. The storm warning was audible. I would have to be careful. Oh. I had been confused as to the purpose of the cables. Not a problem, though. Doing this would not prove a good idea. There would be liquid oxygen, and the pipe would explode. I realized I've forgotten something of significance. would now need a lot of pipes. So here would be the gas that comes in from the outside, and here I would have to guide it back towards the outside. Was the plan that I had so hastily devised. $26°C. I wondered if the temperature would now decrease after all the station was now open to the outside air. But this pipe possibly counted as within the frame, and so maybe we would be fine. Would crossing the pipes be meaningful? I assumed not. An adventurous undertaking indeed. And all of this would just be experiment. I was rather sure this would not get me where I wanted to go. But knowledge was what I pursued, and knowledge is king. And now I would connect.
Two.
This was not successful.
Hydration critical.
Two.
This pipe was in the midst of breaking. I was wondering,
Two.
how was this still the case? 6 megapascal is already sufficient? I realized I was merely moving the problem around.
Power low.
This was not the kind of success I had in mind.
Two.
Why was the pressure only so very slowly descending?
Two.
I did not understand. Just like I could not need delay would happen. did not understand the circumstances. But this had been the first time that I was dealing with a counterflow heat exchanger.
2,
My assumption was that very soon the station would be confronted with a gust of very cold air. But no, the problem seemed to have been remedied. Now this experiment told me at least the following. As long as there would not be anything in the heat exchanger to counterflow, the heat exchanger would not flow. The one end, which was open to the planet's atmosphere, was constantly showing that content, while the other content was empty. I did not understand this. The main problem really, of course, was that what I employed here was the active vent. I should indeed instead choose to use a pump indoors and a passive vent. This would make things much more fetching. And so I decided to do that. First, though, I would have to make 2 insulated passive vents, or rather one. Despite the raging storm, I would go out and show once more my unfathomable engineering prowess. Things.
Waste tank caution.
Words I felt I would probably eat in a few minutes.
Two.
Apparently,
2,
I was not far from the station,
2,
according to the numbers read to me.
2,
Oxygen critical.
Still almost 300 liters of fresh water to drink. The room had descended to 25 degrees, but that had happened earlier already, and I assumed it was
2,
the passive vent. I saw that the pressure outdoors during the storm was even lower than when the weather was calm, but it was also colder.
2,
Since this pipe was not actually at the floor, the assumption was safe that this would now indeed cool the room somewhat.
2,
It was eating 82.3 joules per, let's say, per second. Now I would require a pump. A volume pump. Once more, no gold to do the thing I wanted to do. What? So I asked myself, what happened were I now to just pump the station air into the heat exchanger for a moment? The only way to find out, of course, was to just do it. For administration was surprisingly stiff when it came to documentation. And on the other side, I believe a pipe cowl would do. After all, I just wanted the station air to be piped through the device one time, and then I wanted to see what would result. I was really curious.
Two.
What was happening here was that the gases from the planet in the pipe were cooling the room slightly and were themselves heating up to 25 degrees. And actually, I now saw
Two.
that this must be the doing of the heat exchanger, for the pipe itself could never be so strong. But was there actually gas already
Two.
in heat exchanger? No, there was not. So what was actually happening? I was confused.
Two.
The heat exchanger expressed no flow.
Two.
So why was the pipe heating up so quickly? 1/10 of a degree in such a short time. Why was this happening? Was it really just the pipe leaking thermal energy? I was inclined to wait until it would have reached 25 degrees.
Hunger caution.
Was the temperature slowing down? Yes, it was. Therefore, I could surmise that it would indeed equalize with the room temperature.
Two.
Now I saw suddenly the pressure had descended, possibly because now the counterflow heat exchanger device was doing something. It was still not showing any values.
Two. Two.
Oh. Interesting. I wondered how much throughput this device could withstand. I assumed that the CO2 would eventually become liquid once the pressure would be high enough, but apparently the counterflow heat exchanger was really a very fast device. So I would not have to worry regarding overpressurization. I wondered if this would also hold true regarding the gas that would come from the planet side.
Two.
To find out, I would have to use some cable. I turned down the pump to a minimum, fetched my trusty tablet, which was telling me once more.
2.
And then I turned on the pump. The pressure was basically not increasing. The temperature was decreasing, the room temperature not so much. But maybe I was a bit too greedy.
2.
25.7. And over here, 25.6. I chose to increase the pump's throughput.
2.
Yes, now I saw the temperature descending. Set the pump to max and wondered.
2.
The room temperature was descending, but it was a very slow process. Now with this in mind, I wondered what would happen if I would use the super aggressive active vent for these purposes. But I was really fed up with having to put up switches
Waste tank caution.
and programming and all of these things. I knew this wasn't actually necessary if I would just be once more somewhat ingenious. The idea to be implemented was I would just place a foundation. Ugly as it would be. Should I use iron here for consistency? I did not know, and therefore I just said yes. I was really fond of the arc welder. It would not create any pollution. My electricity was full, no wonder after that storm.
Power critical. So, still, the heat exchanger was cooling down the room slightly, but the room was too massive to take notice. What would, though, I wondered, happen if I would instead use the radical approach of using an active vent for this purpose? Curiosity drills the cat is a saying that humans have. I don't know what a drill has to do with a cat, but that is what they say, and so we have had experiments with cats stolen from Earth, and we could not devise why they would say such things. It seemed it was rather unfriendly, but we would, it was science. We had to use the data measured and try to make sense of it. That's how this works. Where was the active vent that I had? And then I saw it, and I was terrified. No, I was not terrified, but I was terrified. So, and then I printed another active vent. Or I had no other active vent.
Hunger critical.
This approach, I realized, would allow me to operate the active vent from the indoors, making things much more quick.
Two.
And then I switched on the vent, curious as to what would happen. Oh my god, I thought. Even though I did not believe in one, but I had heard it on Earth many times. It was super effective. It had been really effective. The room had cooled down from 26 to 21 degrees. Should I use this cooling technique in the future? Would it be strong enough to countermand the enormous force of a fully functioning furnace? There was only one way to find out. Experimentation requires experimentation, as they say in the historical documents referring to an agency that is supposed to shield the Earth, though we have not perceived them to be actually active these days. And so I was allowed to experiment for the sake of experimentation. Wondering where my volatiles had gone. Yes, I knew. I had done goofed. Well, I thought maybe I would have to disable the capacity of the cooling door for the time being. Removing its logic would not disable me from using it also. There was still the little matter of the manual hatch that I could use. I was curious if my prior measures would indeed have kicked in, so I cut the cable and realized they would not have. The only thing stopped was the arc furnace. That would have been awkward, I thought. It continued undisturbed. Volatiles had been released. All was well. Before I would continue the actual experiment, I wanted to feed it.
Oxygen critical.
Really, it was absolute time. a disco of sorts.
Oxygen critical. Hunger caution. Oxygen critical. Oxygen critical.
And now I would once more heat up the room. Incredibly.
Waste tank caution.
I thought and said it. So it was time to heat up the room, and I hoped that I would not regret my prior decisions. Immediately, the temperature shot up. 40 degrees, 50 degrees. It was a feast. The plants did not agree, but I ignored their will as I so often do. I told them, if you don't like what I'm doing, I have some reserve seats, so you better shut up. And then I turned on the new cooling device. And the temperature descended, actually. Despite the furnace rather growling, the temperature held steady. And so I added some more heat to see if it would be really working. The temperature in the room was holding steady, and it was even rather balanced apart from that one location where the cold was coming from the heat exchanger. honestly, I was surprised as to how successful the cooling was working. All it had taken was a counterflow heat exchanger and 2 active vents. Where was all this heat going, I wondered? Oh. That was not the plan. The filtration unit had been on this whole time. It had been pumping heat into the station.
2,
Which I found interesting, because this means that the station was heated up even more aggressively
2,
by the furnace. So it was holding steady. More experimentation was required. Degrees. The plants were thriving, what could I say? I had never used the Counterflow Heat Exchanger device. Must say, though, that I would use it more in the future. A heat exchange of almost 50,000 joules per second, or maybe even 100,000. because I thought the device was thinking in half-second steps. Time again, I thought, to store some volatiles. Not many though, I didn't have too much. And now I would have to ponder, would I employ this method firmly forever in this room? It seemed to be the right approach. "26, 28, 27 degrees. Why was it so cool in here?"
2,
I assumed it was possibly the cold air that was constantly being pumped into this pipe, which was being heated by the room and was thus cooling it. There was a way to find out, I surmised.
2, 2,
The temperature was increasing rapidly.
2,
It was still increasing rapidly and was not slowing down. So no, that was not the answer. This was, though.
2,
The amount of joules exchanged was descending, while the temperature differential was also shrinking.
2,
Okay, now how could I make this happen in a meaningful way, for the current version was certainly very makeshift. I did not suppose that the Counterflow Heat Exchanger could be built in a vertical fashion. It did not look like that. It had an air foundation explicitly. So I would have to pump in this air, and then I would have to pump in
2,
the planet atmosphere. This could be done in a small place. This place,
Power low.
for example. There could be a pipe here, going outside. The active vent that pumped from the station could be here. This would also mean that... would this be prudent? Sucking away the hot air here, pumping it out as cool air over here, where the heat source was. Would this make sense? "42 degrees. With so much very cold gas available, in absolute abundance on Europa, the cooling solution was obvious. I would use the Counterflow Heat Exchanger and 2 active vents. I would only yet have to clean up the exact assembly that I was using here. So, this could be the input from the indoors, and could then, well, that's not be ideal, but would be doable with some piping. This would be the input from the outdoors with an active vent up there, and could then go back out to the outdoors right here, therefore not using much space. I could move the entire assembly over one bit. This would require me to do some building, and so for the time being I decided to reinstate my makeshift door cooling solution. Which I assumed would now happen automatically if needed. Not in time. I had forgotten to turn off the active vent on the outside. Stupid me once more. Don't nod. You insult me. Aha. So this was still working. CO2 ratio? Almost 2, yes, 2%, I mean 20. Really an oversight that administration had not added the numbers 0, 6, 7, 8, and 9 into the mix. I could not fathom.
Hydration critical. I realized the only possible rotations were the ones I had already found out. And reassembled the Counterflow Heat Exchanger. I wondered if, to make things safe, I should use insulated pipes on the inside of the room. I decided so, just to remove another open question from the equation, the question being, what would happen if I did not do so?
Waste tank caution.
Yes, it was really due time that I would get out of my spacesuit. But I was sure, or rather I am sure, that today I will not get to that point to tell you how that went down. Really, I could not believe the frequency that I required new food and such. It was just too much. Of course, I could improve this, basically double the scales, but double would still be ridiculously often. Anyway, I would wait it out and see. Now, what would I call this pet?
Oxygen critical.
I was looking forward to having all this be done by automation in a proper environment.
Oxygen critical.
Not to mention the proper environment for myself also. 2 months and I had not taken one shower. Yes, I am relaying this to you truthfully, in all openness, fellow Zrilians. It was shameful, but it was a reality I found myself in. At least I was not dead. started behaving in stupid fashion once more. A second active vent. I have found it. Now, there was a claim here that I could place it like this, but I'm convinced that this is not actually the way it works. I would experiment though. Maybe this had changed. Maybe new software had been supplied to, or rather firmware, to this type of device. No electricity cable here. Sad, I was. Sad, in tears, but I recovered quickly. And yes, the answer was this was not functioning. So I took another photograph here of my head-up display to later bring it up with administration once I would have my radio station up to communicate with you, my fellow Zrilians.
Waste tank caution.
I can tell you, us Zrilians out there in a space station have to quite stay on our toes. I hoped to make this smoother and easier soon, and I would, but now was not the time. First, I would have to remedy the cooling situation, and I was looking forward to doing so. Yeah, I was checking the indoor temperature at 28 degrees Celsius. Then I was writing this value to the housing. No more. Then I was writing into register R1 whether the temperature was greater than 35 degrees. Now I decided the temperature shall only be 30, for now I had a smooth cooling solution which would be more fine-tuned, so I could get closer to the temperature I actually wanted to go. I had changed it to 25 indeed. Then I also loaded the pressure, and yeah, that would now have to change. Anyway, then I would say I would have to say that the outside vent's mode shall be 1, and the same for the inside vent. For they both were meant to suck in the air into their pipe systems. And then I would just tell both of them whether they should be on, which would be based on register R1, and that was already everything that I had to do. This was the entire Counterflow Heat Exchanger cooling solution, apart of course from the definitions at the top of the source code. But I was not yet finished. I still wanted to also open the emergency door in case there would be an overpressure event. That I thought would be a good idea. So I loaded into register R0, the pressure, and then checked if it was greater than 95 kilopascals. If so, the outer door would be open, otherwise it would not be. The temperature was descending like it was supposed to. So the cooling solution was at play. 25 degrees had been the target temperature.
2.
No, 25, not 2.
2.
25, not 2.
2.
Shut up. And the cooling solution had stopped running. Now I would have to cable up the door once more so that the overpressure protection would also be there. Then I would check what the indoor air mixture now was. For now it would make sense to mix it correctly. 12%, very good. I decided, let the furnace give me its heat. 300 degrees Celsius. I would now pump this into the station.
2,
Nothing was happening. But then,
2,
I knew that eventually the system would kick in, because the furnace was really weird in the way it outputted its gas. Then again, maybe the problem was rather that the valve had been closed by myself. I used this opportunity
Jetpack critical.
to once again refill the jetpack. Not that this was really necessary. I would have to remember to remove it manually, for there was no automatism here yet. Which was rather dangerous. If I thought about it, my entire survival was hinging on this device not overpressurizing, for if it would explode, everything would be gone. I would be able to rebuild rather quickly. It would take a long time, but I would have tons of resources to draw from. But certainly this was not something I was keen on experiencing. And so I thought about a solution here. I could invoke a sensor, which could be controlled by a chip, which could be inside of this device. And I could actually, I realized, use this device to connect to the gas sensor and automatically increase the CO2 ratio. But I did not want to go this far. After all, this was only a makeshift solution. The cooling was working marvelously. So all it had taken was one counterflow heat exchanger, then pumping in gas from the outside back to the outside through insulated pipes. And here I could see the strength of the exchange. 143 degrees Celsius minus. But during the cooling, it would go up to minus 136 only. Well, and then on the other side the same. This was really easy. I didn't expect this to be this simple. Then I realized that the tank was about to explode, and I tossed it away, which would also bring with it the mining overpressure experiment that I had wanted to make. The downside was now I would have to remake my jetpack canister. Not a problem, I thought. I had enough resources. Or so I thought. Well, not actually a mistake, considering that equal distribution of steel was not a stupid thing to have. Now I was hearing a sound that I was really not expecting, and understood it was the filtration unit that was expecting to give me some gas. To solve this, I temporarily opened the valve,
2,
which immediately solved the problem. Now though, I will have to continue the cycle and run it for some time. Now, realizing that I had just narrowly escaped death, I reconsidered the urgency of the repressurization automation. Where though would I run the source code once again on my temperature control unit? This would make sense, I thought, and so I actually wired it up like this. Where would I put the cable? And then I would have to investigate the explosion site, of course. I must also remember that the explosion had been taking place above ground. Immediately the temperature skyrocketed to 40 degrees. Not a problem. The cooling was kicking in, and I had over 20% CO2, a proud ratio to achieve. The interesting part of this whole endeavor of the cooling change, though, was that now I would finally have to pretend with the station pressure. So far, the cooling solution would just open the door, which would not just cool down the station, it would also make sure that the pressure would be equalized with the planet. Somewhat, at least. Now, though, the pressure would keep climbing and climbing if it would keep pumping in gas through the filtration unit, which currently I had chosen to do. I wanted to see how far this went, and I also wanted to see what the station temperature would do. So far, the temperature held well. Almost. Maybe it was time to change the piping of my CO2 distribution unit. For now, it was no longer a matter of temperature, a matter of door opening, and so I would rather have this hot gas on the other side where the plants would not suffer this much. And once more I realized just how much I loved engineering. The temperature was fine, but now I would turn on the filtration unit again. Immediately the temperature increased to 30 or 40 something degrees, but over here at the plant section it was staying steadily at 25, and so the measure was proving successful, and all it had taken was 1 minute of wrenching. Good ideas and good implementation. And once again, I got the impression as if my station was basically zip compressed. A compressed archive. Every bit counts. Everything placed where it needed to be, and also looking completely fugly. Almost 30% CO2, pressure still increasing. How much was left in the furnace? 3 megapascals. I was almost convinced that we would not reach the critical pressure where the door was supposed to open.
Hydration critical.
I thought it was time to survey what had gathered.
2.
No time. 10 megapascals of volatiles. At 20 degrees, convenient. And almost 100 kilopascals of crap, none of which so far are liquid. So I could still gather 50 times more of this. Then though, I would have to find different solutions. I enjoyed looking at my resources. They had grown quite some. Now it was time to clean up from my experimentations. For order was required.
Two.
80 kilopascals, and the furnace was now basically evacuated. I was surprised how long the filters of the filtration unit had been holding.
Power low.
2.
24 degrees. Perfect. I was proud of the cooling solution. I mean, it was not really my ingenuity that had made this happen. It was someone else's. But I was proud to have found it and established it. It made me happy that everything here was running so smoothly. Well, the next endeavor, so I thought, would have to be the greenhouse. Would it be the greenhouse? Not actually, I mean, I had just evaded the necessity to deal with the gas mixing so much. 30 degrees, 30% CO2 was really plenty.
Oxygen critical.
Alright then, we should not have changed the station in the first place. Okay, so now the gas problem had been solved and we had this very nice experiment with the distance counting, which revealed some fundamental problem with the way the IC-10s are implemented. There seemed to be some kind of detection unit in there, realizing I was so far away it would not do any work. Maybe they called it the laziness feature or the power saving feature, I don't know. I mean, I needed my chips running under all circumstances. Well, but this was not vital, I just wanted to know. So, how were things looking here? Yes, I was still about to make an airlock. and therefore I would need steel. Maybe I wanted to complete the setup. Yes, that would give me a good drive for the next time. For the next, but I was telling you, I would tell you now about the airlock. So that next time you will be eager to hear what I built beyond it. Yes, that was actually what I originally planned to phrase with my language circuitry that is running as part of my biological brain.
Hunger caution.
Would I need the glass? Maybe or maybe not. I was willing to risk that I had counted correctly. I mean, that I was possibly miscounted. This was quite annoying me. I would have been able to place this from here, but I could not. There was just one little thing missing. Then I could have closed the entire thing from here. Annoying? What kind of door would I choose? Well, once more, of course, the composite door. So that I could keep things orderly and label them. Too far away. No avail. The rest I realized I would have to build on the outside. I sighed once more audibly, but you only will hear my words describing that such event. I was considering color-coding these things. Maybe they would be wise. I would admit there was. Famous last words. Nor would I need the flames. As a typical Sunday evening music load, when the ugly neck of the impending work of the next day shows its anti-temporal force, and thus makes everything ugly, already as a preview. No storm, okay. could not leave, I would actually need the walls. Neither could I believe that I could actually reach them. I loved these moments when I would be turning outside, planetary outside, or moon outside, I don't know what the term is here, into inside. When I was taking from the planet and taking from myself and would then also have to contend with the respective pole and atmosphere. Where would be the power supply for this yet other section of the system? Or would this be run by different means? I was not sure. I decided to just let this run as a subsystem of this section of the station. Though I would of course make sure there would be an area power controller and a battery. Chapter 21. And 4 full station batteries.
Hunger critical.
And hunger also. It would make sense to let the power come in from that side, I thought. I had placed it upside down. When would I finally remember it? It was so easy to confuse. Just a binary choice. And it had happened again, which I could not understand. I had assumed that my prior actions had been remembered. But okay. I would be adapting. Now the battery was beginning to charge. I should not push this button, I told myself, even though it was green and smiling at me. This would be an outside airlock, was the plan. Therefore, this might not be working. I was unsure as to how exactly to proceed. Would I place it like this? Yes, this seems correct, though there was the light to contend with. I had once more done goofed. I would of course be able to cable around this, but it was annoying regardless. I must have dropped the screwdriver somewhere. Of course. What would I need to make this happen? There would have to be a pipe on the right side that would return here into this room. This would then have to be, I believe, insulated materials. And so would have to be some other pipes, and so I was fetching just those. I was surprised that this was actually working. And I had forgotten the pipe call.
Health low.
Damn, I thought, and also expressed verbally. This is why I am also now relaying it to you, fellow Zrilians.
Oxygen critical.
Shelf potatoes.
Oxygen critical. Hunger caution. Cognition low. Oxygen critical.
Pipe power. Interesting, I thought. This airlock was basically ready. It had never been used, though. Was it really ready? Huh. Time would tell. What was missing? The connection? Yes. That would have to be insulated. Now this elk could be put into practice, I thought, and placed my disc. I've forgotten something that I keep forgetting every time. The repressurization level. Not a proper airlock, but it would be doing the check. Alright, enough for today. See you next time.